welcome. So today's topic is design of slab. Before going towards design, I will tell you that steps make it easier to understand and remember. And to design the slab, I have divided the whole procedure in total 6 steps. There are a total of 6 steps in which I have divided the whole design procedure. Before going towards the procedure, we require data. What sort of data should we have before designing the slab? Initially, we should have span length f of c prime, f of y, dead load, comma live load, and value of lambda. What is lambda? Lambda is normal rate concrete. It is usually taken as 1. Now this is the whole data we require before proceeding towards our steps. The first step for determining is to determine minimum depth of our slab. Minimum depth of our slab. Depth of slab, I take the minimum depth of slab is L by 20. This value is actually for simply supported one-way slab. This procedure is this formula belong to simply supported one-way slab. Usually in the SPSC papers of Civil Commission, we usually are encountered by simply supported. None of the examiners had ever given a problem out of this simply supported. So if we want to find the value of minimum depth for another beam, so there is also another table. Actually, we didn't require for the preparation of our Civil Commission. So our first steps end here, and in second step we require to find out factored shear and factored moment. Factored shear, factored moment, and factored load. Initially we calculate factored load. This is equal to 1.2 dead load plus 1.6 live load. Then we calculate VU. It is equal to WU L by 2, and then we calculate our MU is equal to WU L square by 8, assuming that this is a uniformly distributed load, because dead load and live load are usually not concentrated. These are the uniformly distributed load. In our third step, we calculate in our third step we calculate reinforcement. To calculate reinforcement, we should have we need RU. RU is equal to MU. RU is equal to MU over BD square. Then we calculate rho, then we calculate AS, and then we find the dia of bars. That's our whole step. The formula of rho is, I will write this formula of rho here. Rho is equal to 0.85 divided by f of y fc prime 1 minus radical 1 minus So the formula of rho is 0.085 fc prime divided by f of phi 1 minus radical 1 minus 2 times ru divided by 5.85 fc prime. This is our formula for rho. Now we will go towards our fourth step. In this step we have to actually calculate phi mn, adequacy of movement. Check movement capacity. Movement capacity. To calculate the movement capacity, we have the formula phi mn is equal to phi as fy d minus a by 2 d minus a by 2. For this we need phi is equal to 0.9 and a is equal to as fy divided by 0.85 f prime b. This is the formula for moment capacity. We can calculate the moment capacity from here. Now we should also remember here that this should be greater than or equal to mu. Okay, now the fifth step is checking the adequacy in shear. We need to find out phi vn, and that should be greater than or equal to vu, and it should be half of times. Half phi vn should be greater than or equal to. So we have the value for phi vn. It's not vn actually. Usually we phi vc, it is usually named as phi vc, and the formula for phi vc is equal to phi 2 lambda radical f of c dash b and d. This is our fifth step, and after calculating fifth step we calculate sixth secondary reinforcement. And to calculate secondary reinforcement, we knew area of secondary reinforcement is equal to rho bd. Rho is equal to 0.018, and we actually calculate this. And after doing this, we have to actually calculate the whole of our design. So this is our complete design procedure. This is the 6 steps. We follow these 6 steps. We are all done with design of one-way slab.